Hi, everyone. I'm Carl Rochelle. I'm the CEO and founder of System 76. Thank you for joining us this morning. I'm with Britton and Jeremy Soller. Britton is a mechanical engineer. It's in charge of the Thelio project, Thelio Astra. And Jeremy Soller manages the software engineering team. So all the development with regard to operating systems and ensuring that operating systems are optimized for the hardware of the products that we build. So today we're here to talk about System 76's first ARM desktop or ARM product in general. And it's Thelio Astra. Thelio Astra is a unique ARM product. So a lot of times when we think about ARM, we think about low power devices, low power laptops, phones, other devices of that nature. But Thelio Astra is the opposite spectrum entirely. And it features a 128 core Ampere processor, up to 512 gigabytes of octa-channel memory, and up to a RTX 4090 GPU. A lot of customers for Thelio Astra will be using like A6000 ADA processors or ADA GPUs because they'll be doing machine learning on this machine as well as inference on the Ampere processor. It's a mid-tower case and it's only 40 liters. And what's really unique about that is in that 40 liters, we have over 700 watts of performance. So it's a small footprint that you get a lot of performance out of. This product in Thelio Astra is designed and engineered for engineers. So it's intended for engineers that are developing for ARM endpoint devices. A lot of those are, these days, even those endpoint devices are becoming more powerful, especially in the automotive industry. In automotive, the processors on the car are taking in information from hundreds of different sensors to make decisions for autonomous vehicle or autonomous driving, for safety systems, and for software-defined vehicles. And what's unique about Thelio Astra is you have both the powerful GPU and CPU. So it's the entire stack that you're developing for your automotive vehicle and the endpoint device all in one desktop. So you can work on your machine learning models on the GPU and do the inference that you'd be doing on the CPU. So with that, I'm going to pass it to Britton, who's going to talk about the amount of performance and how we get that amount of performance in a small 40-liter chassis.
So one thing that sets us apart at System 76 is that we design our computer desktops around its components, such as the CPU, GPU, and motherboard. For Thelio Astra, this allowed us to make a very powerful computer and a small footprint that can easily fit on your desktop. We decided to make modifications to our current Mira chassis in order to accommodate these new components. And most of the design changes we made for this system were actually for thermal management and thermal system changes. One thing we found to be very effective for this that we use across all of our desktop lines is that we have a separate CPU duct, and this allows the CPU duct, the CPU and the GPU to have separate air intakes and exhausts. Here you can see the intake for a CPU duct, and the way this works is if, for example, you are rendering and your GPU is stressed and it's producing a lot of heat, then this CPU duct will prevent your CPU from any kind of thermal throttling because it has its own cooling system. And this allows both the CPU and GPU to maintain performance and prevent any kind of thermal throttling. And it also works the other way around. If your CPU is the one that is stressed, then your GPU will maintain its performance. Some other changes we made to accommodate the higher power Ampere CPU is that we chose a larger cooler inside of the CPU duct. We decided to go with air cooling versus liquid cooling. This is because we can get the same amount of thermal performance and you don't have as many failure points and there's not as much regular maintenance that a fan would just need. Another change that we made is we made this CPU duct intake a lot larger to allow more airflow to reach your cooler. This increases its performance. And another change that we made is the rear duct fan for the exhaust fan in the CPU duct. We made a special duct just for that inside of the CPU duct, that seals it off against the rear panel. And this prevents any kind of hot air recirculation from staying within the CPU duct itself, and make sure that all the hot air is exhausted. Another thing that we use is thermal testing. We do lots of iterations of thermal testing where we stress our CPU and GPU to the max. During this testing, we make sure that we prototype our design so that there's no thermal throttling of the CPU or GPU, and that it's operating at its max performance. And we also run acoustic testing at the same time, where we optimize our fan curves and make sure that our desktop is as quiet as possible. What also helps us with the acoustics is our Thelio IO board. This allows us to control the speed of our PWM fans and create custom fan curves. And I'll hand this over to Jeremy to talk about the Thelio IO board in a little bit more depth.
Yeah, so Thelio IO is an open hardware, open source, and open firmware design. And it's integrated into all of our Thelio chassis. And what it does is it integrates information from the operating system into the fan curve. So we're able to read the GPU temperature, we're able to read the CPU temperature, and other operating system information that normally the motherboard has no way to inspect. So we're able to produce a quieter and more effective fan curve than the motherboard is able to, while ensuring that the system never throttles and is as quiet as possible.
So one of the innovations that are happening in the automotive industry is software-defined vehicles. That's important. I think there's a great anecdote that I recall when Model 3 was developed. Consumer Reports was testing Model 3 braking versus BMW, and they found that the BMW's braking was far more superior than that of the Model 3. Well, what Tesla was able to do, because their vehicles are software-defined, is modify and improve the braking system over the air with a software patch. So for an automotive company, the difference is, you take what you're doing is taking these mechanical processes and making them software-defined. And instead of perhaps recalling 10,000 automobiles and sending them to a technician to improve braking, you can now do that over the air. So it's a massive improvement and innovation that enables automotive companies to improve their vehicles, their fleet, without massive recalls and at much lower cost. But all of that means a whole lot of development, and that development comes, of course, with a cost. That's and for a lot of developers today, as any engineer will tell you, one of the most annoying things is waiting to test your code. And if you're doing ARM development with emulation on x86, it takes a long time to get from code to testing. When you're doing it natively, you're getting there immediately. And especially with power of Ampere processors, 128 cores, you're compiling in seconds rather than minutes or hours. The other way that a lot of companies are kind of approaching this problem of ARM development on either weaker systems or emulation is doing it in the cloud with something like Graviton on AWS. But as a lot of our customers are expressing to us, the cost per user it continues to increase as they take advantage of these cloud platforms. And the difference with Thelio Astra is you buy this hardware once and you use it forever. You own it, and you're using it for the cost of electricity. So not only are you able to develop faster, you're also able to develop at a lower cost. I think there's a general trend of really looking at the cost and value of doing things in the cloud versus doing it on-prem. And a lot of times that equation is starting to come out on-prem these days. In conclusion, I just want to talk a little bit about System 76 and what makes us unique. We're an 18-year-old company and specialize in Linux computers. And we're an engineering company. So we have teams that engineer everything from firmware to operating systems to hardware, and build all that hardware here at our factory in Denver, Colorado. So behind us we have lasers and brakes and paint shop, and the entire process. We take raw materials in, and at the end of the day, we ship out a complete product. And engineering is done in the same location. That means if Britton has an idea or a concept, or Jeremy or anyone else, then we can take that concept, we can prototype it in minutes or in a day, and quickly iterate. And the end result being we're able to build a much better optimized and just better value product for our customers. So that's Thelio Astra, and it's and the Ampere platform. Now I'd be happy to take any questions that you have, and we'll go from here.